Hi, I'm Sarah Kaiser, and I'm going to be giving this presentation over open source security using their tools for an integrated cybersecurity. So to start off, I wanted to introduce myself a little bit. I know with COVID and this being an online course, like there's not a whole lot of face-to-face interaction, so I found it really important to show you who I am and a little bit about myself. So this picture over here on the left is of me, and then this picture on the right is me and my family. I'm 21. This semester is my 6th semester at Texas A&M University of Commerce. I'm going to graduate on April 30th with my bachelor's in computer science. Currently, right now, I work at L3 Harris as a co-op software engineer, but whenever I graduate, I'll start full-time in June. So being a software engineer, this topic was really interesting to me because I work a lot with open source tools. I also work with proprietary software, but I thought it was really interesting to kind of learn about it and get an even better understanding of what it is, because you hear those terms a lot, but to really dive in and figure out what it all means was really neat to me to learn about. So let's start off with open source software history. The open source label was created on February 3rd, 1998 in Palo Alto, California. Open source software was not originally created with the intention of it being as successful. It was created to kind of get a revenge on proprietary software. Mike Volpe says, "The original open source projects were not really businesses. They were revolutions against the unfair profits that closed source software companies were reaping." So some people felt that they were getting ripped off by proprietary software because it can be very costly and you don't even get to access the source code. So open source was created to kind of get a revenge, you could say, on proprietary software. People were tired of not being able to access stuff and spending so much money, so that's kind of how open source software evolved. This idea of open source became really popular in the 1960s, and it was created so that software users and developers could collaborate and improve source code from this collaboration. It allowed them to really work together, and like I said, it was a less costly option, and so some people found that it was better than proprietary software. The open source label was founded in the Open Source Initiative, and it was originally founded by Eric Raymond and Bruce Perens, and Eric Raymond was the first president and Perens was the vice president. So what is open source software? Open source software is a source for knowledge sharing on the topic of source code. So this means that people can edit the source code, and it's really a good tool for learning because you can study how other developers would write their source code and you can get tips from that. It also, just reading different code is really great for learning, and it also gives you the chance to collaborate on it. It is a medium for developers to collectively work on and improve the code together. So open source code is really dependent on collaboration, and it's weakest whenever only 1 or 2 people work on it. So it's really meant to collaborate with other developers and really use more than one brain, you could say. So I have this video. It's like a 1-minute video. I think it helps to kind of show what open source culture is. So I couldn't figure out how to get the audio on my computer to show on the presentation, so I'm going to be using an outside soundbar, so just bear with me for 1 second.
What is open source culture? Imagine you baked a cake. And then shared it with everyone for free. Anyone can add to it to make it better. What is open source culture on the internet? Do you watch YouTube videos? Do you use Wikipedia? These websites are shared with everyone for free. And anyone can add to them to make them better. That's what open source culture is.
So I thought that video was kind of helpful in describing what open source is and how other people kind of view it. The one thing that I'd like to point out from the video is that it says that it's free. Technically, it's not free. It can be kind of viewed as free because proprietary software is so much more expensive that people are almost like, wow, this alternative open source software is kind of almost free. And it's also free in the sense that users are free to do whatever they want with the code to a degree, because open source software requires a license, which is what makes it not free. It's because you have to purchase some kind of license in order to use it. There are two different types of licenses. There's a permissive license and a copyleft license. A permissive license allows users to be at free will with the code and do whatever they please with it, as long as they understand that there could be bugs and they can't hold the license company responsible for those bugs because they're using that code at their own risk. It also requires them to give credit where credit's due. So they can do whatever they want with the code, but they need to give credit to the author of whoever originally wrote it or created it. Some examples of this are, of these licenses are MIT, Berkeley Source Distribution, and Apache 2.0. So now let's talk about a copyleft license. A copyleft license is a little more strict and it has more guidelines. This license requires that source code has to be shared with 4 distributed binary files, and the license makes it so that there are no extra restrictions that can be just randomly placed onto the license holder. So say a user is using it and then the company decides that they want to change their guidelines, they can't just randomly throw that on the user. The user has to agree to it. They can't just throw it in there and then the user doesn't know about it and then they get in trouble for it. The copyleft license makes sure that this does not happen. This also makes it so that copyleft terms are permanent and they're non-changeable by the license holder, which is what I just explained, that they can't just go randomly change the license agreements on the user. Some examples of this are GNU General Public License, Mozilla Public License, and GNU Affero General Public License. How to choose which open source software to use. It's really important for someone who is thinking about using open source software to perform very thorough research and explore all of their options. There's a lot of documentation done on open source software, so it's really important for a user to really dig down into those and explore all the security risks, all of the vulnerabilities that have happened, any public exploits that have occurred, anything that could be wrong with the software before they go and make this decision. Of course, it's also important to explore the positive sides of it, but you really don't want to get stuck in an open source software that has a lot of security risk with it. And whenever I say stuck, though, I say that lightly because one of the benefits of open source software is that you can use it flexibly. So you can use it in a trial and error sense. So you can try one out, and then if you don't like it, it's really easy to just stop using it. It's also important to look at what's popular. What are most people using? Because people aren't going to be using something that's filled with bugs or that's not dependable or not doing the job it's supposed to do. So it's important to view and look at what's popular. This image over here on the right is the Battery Open Source Software Index from a TechCrunch article. This list was created by the authors of this article, and it's based on 4 factors. These factors are public interest, user activity, job impact, and impact in the open source community. So you can see here that it's ranked 1 through 25. Linux being at the top, which is very popular, and then Git and MySQL. So there's several on here. And this picture and this TechCrunch article can be used as an example of what you should look for whenever you're doing your research on what open source to pick. This also goes to show how popular open source is, the fact that there's 25 options that are listed in the high rank categories. So it's just showing that open source software is really making its debut and is becoming popular, or has become popular. What is proprietary software? So I realize that this presentation is about open source software and the tools it can be used to build an integrated cybersecurity, but I also found it really important to discuss proprietary software because that's the main competitor of open source software. So whenever you're deciding whether you should use open source software or not, it's really important to go look at the other options to make sure that you're making the best choice possible. So proprietary software is copyrighted and it restricts the user's usage, distribution, and modification. The restrictions are made by its publisher, and it's usually owned by an individual or company. So, for example, Microsoft is a proprietary software company, and they are the only ones who can edit, and any of their sales comes with a license, and you have to follow these strict guidelines. It's much more strict than open source software. Their source code is closed. You cannot edit it. Only the developers and workers of the Microsoft company have access to this source code. Some examples of this, as I mentioned, are Microsoft, Adobe, iTunes, Adobe Photoshop, and PS3 OS. There are obviously a lot more examples, but those are just a few of the most popular ones. And like I mentioned, whenever a user uses proprietary software, it comes with an agreement, a license agreement. This is called an end-user license agreement, and it serves as a guideline that limits what a user can and can't do with the software. So here is some comparison charts over open source versus proprietary. I really find this one interesting. It's comparing in these different categories. So for example, technology / flexibility / extensibility. Open source software has it beat pretty well. And then I find the most important one on this list is the security bar, because here the orange is open source saying it's better. And people have voted that open source is better for security reasons than proprietary software, which is the whole point of this report, right? The only thing that proprietary has open source beat on is reliable support / consulting services, because it's a company based on closed source software. So if there's an issue and people can't get to that issue to view, then they need to have a really good technical support, whereas open source software kind of lacks in that a little bit because people have the ability to go and view the software themselves and figure out what's wrong. Is that a downfall? Yes, because sometimes you just need help or technical support or someone who's in charge, but it's kind of one of those things that it's a risk that you have to be willing to take. So I have another quick 2-minute YouTube video that explains the differences between open source and proprietary software. And again, I have to do the, I have to do the sound over here.
Every piece of computer software is created using source code, or the technical blueprint that tells a program how to function. When creators release their finished product to the public, they must decide whether to make their software open source or closed source. With closed source software, also known as proprietary software, the public is not given access to the source code, so they can't see or modify it. But with open source software, the source code is publicly available, and programmers can see or modify that code if they desire. Keep in mind that you don't have to read or change any code in order to use an open source product. The vast majority of apps, games, and other popular software are closed source. However, there are open source options for many types of programs. If you want an open source alternative to Microsoft Office, you could use LibreOffice. Instead of using Windows, you can try an open source Linux operating system. Other open source examples include the Firefox web browser and WordPress blogging platform. One of open source's biggest advantages is that it's usually free, though some features and technical support may cost extra. Also, since the code is available to anyone who wants it, public collaboration can find bugs, add features, and improve performance within a relatively short amount of time. With that said, open source software is not perfect. It may not be as user-friendly as closed source software, and if you run into trouble, it may be difficult to find technical support, especially for less popular programs. As for closed source software, it's more likely to be a stable, focused product, and if you need support, customer service is typically easier to access. However, closed source software often costs money, and if it has any bugs or missing features, you'll have to wait on the creator to address the problems. Now that you understand the difference between open and closed source software, you can take advantage of the type that best meets your needs.
So I like that video because it explains the differences. I know I kind of touched on them already, but I'm a very visual learner, so I found that watching that video really helped me to understand it. I like the part at the end where it says that it's best to choose which one works best for you, now that you know the differences. So I just think that's a really good thing to keep in mind, that even though this report is over open source software, it's not always going to be the best choice, and neither is proprietary software. So moving on. Now we're going to discuss a little bit of the risk of open source software. Not all of the content is created at the same time or equally. Some start out with vulnerabilities and others can develop over time. And tracking these vulnerabilities are very dependent on communication. So it's really important that whenever a user finds a bug, that they don't just feel like, oh, I don't feel like reporting this. No, they should report it, and so that other people are aware of it. So it's very, very communication heavy, but the tracking and where users put the bugs is so widespread that it can become a lot for just a user to manually follow. So they usually have to have tools to maintain and find all these bugs, which can be a hassle in itself to have to use another tool in order to track these. Open source software also puts public exploits at very high risk, because any bug that's found is reported to public places. For example, the National Vulnerability Database is a public database that has all these bugs listed. So any hacker that wants to hack this open source software has access to all the bugs, where the bug's at, how the bug's working, etc. So it's kind of a security risk in the fact that they can do that. But there are also some advantages to open source software. One of them being that it's very transparent. There's no question about what you're getting. There's no source code that's behind closed doors like in proprietary software. You know exactly what you're getting. You can see everything. You have access to everything. You can edit anything you want to, and there's no false advertisement. The code is also continually tested. So there's constantly people working and editing and debugging this code. So you know that it's secure. You know that there's always going to be someone looking at it and testing it, because anyone who's using it wants to be secure for themselves. So in that, it'll be making it more secure for any other users as well. And it also kind of goes with the saying that 2 brains are better than 1. So there's multiple brains and eyes on this code, and it's continually being tested. So that makes it a security advantage. This also goes hand in hand with that security patches are patched almost immediately. So if there's always eyes on the code and always people looking to improve the code, then that means bugs will be found sooner rather than later, and that also means that security patches can be deployed sooner rather than later, and people will come up with these security fixes and then they'll send them out. It allows for more flexibility for users, so it gives them the choice to shape the source code however they need to, whatever best suits their needs. If it's a company looking to build an integrated cybersecurity, then they have the option to shape the source code into exactly that and use it for however they need. Open source software allows for more sustainability, and it is more competitive and keeps up to speed with technology advancements. So due to the nature of open source software, the code is continuously updated and improved. And so this means that since it's always being improved, it's always going to be very sustainable, and it's always going to be keeping up with technology advancements. You don't have to wait on, in a proprietary software, you have to wait on for the company to deploy these changes. And since it's a little more difficult, I would think, for a proprietary software to deploy all these changes, so then keeping up to speed with technology is less likely than it is for open source software. Using open source software for cybersecurity. It allows the company to be in control of how their security measures are implemented. Using open source software is more flexible for the company, and they can use it to fill in any security vulnerabilities. Bugs are inevitably going to be found in any software you use, whether it's proprietary or open source. So the fact that you can collaborate in open source and they can be found faster and security patches can be deployed faster is a really big plus to open source software and using it for cybersecurity. Open source software allows for integration because developers can study other methods of coding and share ideas. So kind of the last slide where we were discussing advantages is basically the reasoning why you would want to use open source software for cybersecurity. And if you'll remember back to the graph where even other people voted that open source was a little more reliable for security versus proprietary software, then you have your reasoning for why you would want to use open source software to build an integrated cybersecurity. It's just more flexible. People really like that they are able to use and see this software, and they can be in control of their own security. They don't have to rely on anyone else. They're not worried about what's going on behind closed doors. And just integration is really important in technology, and sharing ideas and learning from others. This conclusion graph, I just wanted to include it to show you that there are several people who rely on open source that are very popular. There's the PHP, Java, JavaScript is really, really high, .NET, Python, and Ruby. So all of these are well-known languages that rely on open source software. So that just goes to show that open source software can be reliable and used to build an integrated cybersecurity. Thank you for listening.